Restream is usually the first. Check, check. Twitch is usually the second. Hello, Twitch. Hello. Jeez. Nope, no Twitch. Uh-oh. Nope. Restream says we're on Twitch. My Twitch dashboard does not agree. Nope, there it is. All right, and YouTube is on as well. And I think we're good. Sweet. All right. Welcome to Code Hangout number 196. Hey Neil, how are you doing? Yes. So I thought about how to go about this, and basically I was actually thinking about how I can describe the algorithm I'm working on to you guys. And I thought, you know, I don't want to just write down some words. I want to visualize it. I want to show something, and I keep thinking about how to do that. And then it occurred to me that, you know, visualizing things related to Sudokus is something that's been on our to-do list for a while. Hello, Ictus. Oh, I don't know how that one works. So, there's a couple of things I want to do. There's some basic things I want to do within SudokuPad, but I probably also want to do some basic things outside of SudokuPad, because ultimately the SudokuPad renderer needs an overhaul as well. Especially if I want to make it easier for myself to modify things in the grid and animate things in here. But one of the first things I want to talk about is this 5x5 matrix, because that's what I'm using for my distance algorithm. Basically, the idea is that I theorize that within a 5x5 box around a central digit, you will always find another copy of that digit, or you always find a copy of that digit in any other 9x9 grid. So, for example, if you look at these cells in a corner versus these cells near an edge, because 5x5 will always ensure you're basically including at least a 3x3 box, right? So if we're looking at this one, we're kind of looking at this, right? So I think that's the minimum number of cells we need to look at. And then the way I figured is, so if we're looking at this cell, these would be our closest cells. These would be our second closest cells. These would be our third closest cells. Whoops, make these yellow. Then we'll have these cells as our fourth closest cells. And finally, these are our most distant cells, right? Ictus, all right. So that means I can pre-calculate the distances for all of these. And then what I can do is for every cell of the 81, I can pre-calculate the indexes in the order of the distance, right? So I can say, okay, the closest one to this is this cell. So cell 0, the closest one is cell 0. Cell 1, the closest one is cell 1, right? Now, the second closest for cell 0 is this one or this one. So I'll just put these as second and third closest. And for this one, it'll be these three, etc. So basically, for every cell, I can pre-calculate a list of cells with their exact indexes into the 81 string thing and the exact distances. And that makes it really, really fast to calculate the distance of a 1 in one puzzle to the 9 digits in the other puzzle, right? So that's basically what I do. So I basically say, okay, for every cell, you know, let me look at that cell. I just want to find the distance between this cell, and I want to get a list of digits, right? And basically what happens is, in the end, I'll get a 9x9 matrix where each, where along the columns would be the digits in the first puzzle, and along the rows, or in the other dimension, will be the digits in the other puzzle, and the numbers would represent the distance between, you know, let's say, between a 1 and a 1 in the other puzzle, right? And if it's the same puzzle, for example, those distances would always be 0, right? And that's kind of what I showed, I think, yesterday. I think I ran this. Let me rerun it. I just switched it to benchmarking, but I can just output this. I think I can do mat print, because this should output a 9x9 matrix, right? Maybe not. Oh, no. Okay, yeah, I'm converting it to a single number. But if I output this, and if we skip the benchmarking, yeah, if we don't calculate totals here, and we'll go mat print the sums array. Yeah. So these are basically between two puzzles. But if I calculate against the same puzzle, so we'll take this puzzle against itself, right? So now we'll get 9s along the center row, right? And the reason for that is because I'm inverting it, right? So basically I say, okay, what's my maximum distance? So by dividing each distance by the maximum distance, I get a value between 0 and 1, then I can invert it, and then I can square it. So I can increase that, right? Which means then I can take the square root, I can sum these together, get the square roots, yada, 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 right? In fact, what we can do here is we can actually do, just quickly to illustrate that, but it's not a calculation we actually need to do like that. So we can divide it by 9, right? That gets us our average. So these are squared, but because they're between 0 and 1, they're going to remain between 0 and 1. We divide them by 9, and we'll take the square root. I am not entirely certain if this is mathematically accurate, so we might have to review that. And that's part of why I want to describe it to you guys, so you can kind of poke the holes in it and figure out what I'm doing wrong and all that sort of thing. Yeah. So now here, the diagonal is the 1s, right? I'm not getting a 1 in the first one. Wait a second. What's going on here? Let me see. Ah, no, I had some wrapping. Yeah. So basically 1s would be perfect matches, right? And 0s would... well, you can't get a 0, right? Well, I guess a 0 would be if they're always exactly the maximum distance, since I am dividing by the maximum distance, right? So if we're dividing by the maximum distance, if this is exactly the maximum distance, it should become a 1. And if we invert it, becomes a 0, right? Yeah, so a 0, an exact 0 would mean that every digit is the exact maximum distance away from every other digit, right? Being this. And I'm not even sure if that's possible, right? So that's kind of theoretical. What I haven't quite figured out yet is how to turn this 9x9 grid into a valid single number, right? And of course, the other thing is that here we have a lot of values in the middle ranges, and it might be because of the squaring and the square rooting I'm doing, and it's also because the choices of digits that are closer than the maximum distance is fairly large, right? So the odds of there being a digit, for example, all the edge digits have a digit minimum. Well, very few digits will have one at the maximum range. Anyway, so the odds of there being matching digits at the maximum distance are super low, right? So we're gonna probably, and in fact that's what I should do probably. We'll get like a bell curve distribution, right? I don't actually know how to graph this easily, but what I can do is, if I take this, right, and I'll replace all these spaces with tabs. I put a tab here. Place all. Then I have to save it, and then I have to 9x901.csv. So if I do something like this, right, and then I'll do the new Google Sheet, and then we'll do that. Oh, can I just do that? Yeah. All right. So we can get that into a Google Sheet like this, and I could now say we'll add a row to the left, and this is just like I'm quickly running through what I've been thinking and doing. So column to the left, insert column, row above, right? It'll be digit. So we'll say A-1, for example, A-2, right? And I think I can just, yes. And then this will B-1, B-2, and we can just grab that, drag it over this way. Yeah, so that's puzzle A digits 1 through 9, puzzle B digits 1 through 9. And now we should be able to graph these. Insert chart, right? And we should have we should be able to say row 1 is headers, column A as labels, right? So we should have these series. We have the spikes on the ones, so that's because we're looking at the puzzle of itself. So this should really be a 2D graph, and I don't know if we have 2D graphs here. But let's say if we look at an individual series here, so if I say series, right? If I can remove, 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 and remove. Right, so this is the graph of the digit 1 versus the other digits, right? So digit 1 is a perfect match with digit 1. You can see it's a slight... The second best matches against 2s, the lowest matches against 6s, and things like that, right? I think this might be useful in a sort of 2D search space. And the idea is basically... But these are all super similar, and that's kind of one thing I'm concerned about. The other nice thing is because of the way the lookup table works, this algorithm is actually almost the same speed as the matrix multiplication algorithm. Like, there isn't a lot of math happening, actually. And I don't actually go through the numbers very often. So I'm probably looping a similar amount of time. So including the calculating the exact distance versus the digits doesn't actually add a lot of extra time. Because I'm not actually calculating them, right? I'm just looking them up. And you could probably optimize it as well by pre-calculating, like if I have a list of where all the ones are, and like if I basically create nine cell arrays, so digit 1, what are the 9 indices where digit 1s are on the board, etc. Anyway, so what I want to do is I want to use this sort of as an excuse to kind of help me start to work on the animation system. Sort of like, okay, I want to create a 5x5 grid with the distances that I'm calculating, which I'm just pre-calculating here. Yes. How would I go about doing that? I want to be able to, for example, animate this grid being overlaid on a puzzle grid and going digit 1, digit 2. And then I want to have a second grid. And I want, let's say I want this grid. Let's say if it's like this, then I want a highlight go here, and then highlight a second grid, and then say the digit, and then connect these two digits, do the math for the distance, put them in another place, and then do the second one and animate through that. And that's the sort of basic stuff I want to be able to do in this animation framework. And this is not the main application for that, but it'll be a good sort of guide, like, hey, what are the kind of things we want to do, right? And I'm currently a bit torn if I should start with, like, messing around within the SudokuPad engine, or if I should start from scratch. I think I'll do a little bit from scratch first, just to get my head around things, because ultimately I want to be able to refresh or update the SudokuPad renderer anyways, because the SudokuPad renderer currently isn't where I want it to be, right? I do want to base this still on SVG, so it'll make it a lot easier, but ultimately I'll, SudokuPad already is able to render things into, where's the thing? Where's the thing I was looking at? This one, right? Minimize these. The current renderer, so the current renderer, for example, I already have the technology to generate a GIF animation, things like that, right? Now, we probably don't want to create GIFs for everything, but for some things, A, it might be useful. B, running it in the engine is perfect for our users. And C, I can do a local version that generates FFmpeg from the GIFs, or even from a set of SVGs, right? Or, using a WASM compile version of FFmpeg and generate the videos inside JavaScript, right? That's all doable nowadays. So, all right. So let's have a look. We probably want to do some stuffs like nope. Doing at event listener and code it. Something like that, right? And then we'll have const async main equals async, like that. Let's do that. And that should just execute main, right? So if I put a little console here, and I have to be a bit wary because I don't actually have all of the screen visible on my stream. So we're gonna do something like that. All right. And then we'll probably want to do a little bit of styling, HTML body to get rid of any kind of spacing that we'll have in here. No, wants me to put all of it here. Oop. Refresh. Here we go. Yeah, so we want to get rid of the spacing there. So we'll do margin 0, and we'll do width 100%, like 100%, right, and no padding. Right. Okay. So, and then the rest I'll try to add programmatically. Now I'm gonna reference back my own code, my old code, the current code in the engine, because manipulating SVGs is not super trivial. It's not hard, but I just wanna not waste time trying to remember things. So if I go straight to the renderer, actually, if I go to the puzzle tools, I go SVG here. Data to I think if I say create namespace element or something like that, create s, create s, yeah. So if I look for that in our puzzle tools, or in that whole code paste, because I'm always pulling it out. Ah, here we go. I want to see what it looks like to generate something from scratch, right? So can I do this? I think that should generate an actual SVG element, right? Yeah. All right. So we can do something like let g equals something like that. All right, and then document.body.insert element. No, wait. Append child to G. Right. And then let's append something to the SVG element. So we can actually display it there, right? So we can do something like create element. So if I do something like rect, let part equals that. So then we'll do part dot and what was it? Set attribute fill red and part dot set attribute width 100, right? 100. Now I don't know if I have to use px or whatnot. Unexpected token. Did I get something wrong in here? I'm looking. Ah, here we go. So we have an SVG here. So we should be able to say SVG append child part. right? There we go. Okay. So we have an SVG, we can add things to it, right? And then we should be able to do things like the grid. And the grid lines are actually rendered quite fancily somewhere over here. Render art, render text, render grid. Grid lines, yeah. So we do this, and okay, so we have these functions that help us do certain things, right? Such as taking path data and turning it into something more useful, right? Let's have a look. If we need anything other. Okay, so for example, here it has the cell size units. We can probably remove that from in here. So instead of multiplying by cell size, we'll just have this and this, right? We can do something like that. And we can look at what something like this looks like. So we can say, hey, if we execute this on an array of 0, 0 to 1, 1, what does it actually look like, right? One of the things I don't like too much about this here is that it doesn't give me a more immediate feedback. Oh, that needs to be an arrow. It was asking about. Right. So, oh, I hate when it does that. It does a weird refresh. Yeah, so it converts the set of lines, but I believe it doesn't let me do separated lines. Lines.map. No. Okay, so we can do something like this. We can do something like this, right? Let's just hard code this quickly. Rows and columns. 9, right? Oop. I'm just hitting keys on my keyboard. So if we look at the raw data of these lines, and then we'll look at it in here after the conversion, and we're basically trying to convert something more useful like this to something within the SVG, right? Now, in the SudokuPad renderer, everything is multiplied by, the cells are internally 64 units wide, which is completely arbitrary. We could make the cells 1 unit, right? And then we'll just use fractional values. But then fractional values are actually, they add additional characters to store them and so on and so forth. So we'll probably want some sort of arbitrary scale, right? And we'll probably put this in a constant here, but ultimately that scale should be variable, right? So ideally we have algorithms that can modify, that can go in there and change the scale after the fact, right? So ideally what I want to get to is, I want to be able to store the SVG in a precursor format. So something like this, right? And then have that being converted, right? So the rectangle, we have some JSON that defines a rectangle, and we have a JSON that defines a path, right? And it can convert that correctly. So let's see what that might look like. So let's say let rect, we'll make that a object, and we'll just say, we'll just put these properties in here, right? So we'll just say it has the fill red, it has a width of 100, a height of 100, right? Now, what it doesn't have is the actual type here. So we either put the type in here and call it rect, right? The only problem is that will cause a collision on the type value here. So we might have to figure that out. And then we want to basically wrap this up. So we want to do, we'll want a function here. So I'm just creating some really basic, tools. And we'll just say SVG render art, right? And then we'll just say SVG part. Or we'll just call it parent, right? So then we'll do something like part equals yada 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 part type, and we might in the future have a default type there, and then I think I can just reuse whatever we're doing here for find set attribute. Yeah. And now I'm remembering. So we had type and then we had attributes separately. So we'll have something like that. Okay, for now, let's do that. But the idea is, hi there, hi myself. The idea is that I don't just pass this in, because in the current render, this gets passed in and the data is just sort of floaty. But the idea is that a whole SVG can be described in these and get rendered at any time, but also modified still at this higher level, right? And ultimately, it would be great if I can, have a conversion from SVG to this data as well. The problem with that is kind of like you want to only have the attributes that are different from the default, right? But we might figure that out. All right, so we'll do for const, we'll do name val of object dot entries art dot attrib, right? We'll do something like that, right? Name val art has already been declared. Oh, yeah, we'll just do that. And then here we'll do SVG render part. Let's close that for a sec so we have a little bit more space. We'll do SVG rect. Right? And we probably want to kill that. And we got to see why the music stopped. Not loading. That's a bad sign. That's my YouTube, my stream. All right. My stream still seems to be streaming. My YouTube just doesn't work now. Okay. All right. I don't know why that happened. Let's continue from here. Okay. So we have the properties here. Then we should be able to set attribute on the element, right? So we'll do element set attribute name val, and for now we just kind of do this blindly. In the future, we also want to be able to set the parent on the part itself, right? But the parent might actually be defined within this kind of thing. We're kind of building our own sort of minified DOM here. Missing question mark. Oop. Ooh, name. What the name? All right. And then that should get us a SVG element, right? And then we should be able to do parent.append child part. Something like that. All right. So we want to be able to do something more complex than that as well. So we'll do something similar. We'll do something like let path equals And this is, what kind of element is it? It's a path element. Yeah, okay. So we'll do this, type, path, right? Attributes, D. Ah, you see, and now that's the question. So here, D should go through the RCS process, the RC to path data, right? So, and that's kind of now where the stuff happens, right? I think for now we can do this, but going forward, we obviously potentially want to support other kind of lines, right? Like curves and stuff. But for now, we're just gonna make this an array, something like that, right? And then we'll just say lines equals path.atch.d. And then path, right? Let's prefix these with the word part for now, just to kind of distinguish them, and that we don't get any naming conflicts and stuff. And then this should be a string, right? And maybe we'll put a console.clear at the top, so a bit confusing. Okay. This doesn't seem to execute now. Do we get any errors? Yes. So I don't know why this console doesn't output these errors. That's a little silly. But okay. Parameter 1 is not of type a node. Compiled on element, not part. Here we go. Okay. So we'll get something like that. But what we need to do now is, when we have these kind of special things, we'll do a bunch of checks in here, right? So for example, if, and we'll probably something like this. We'll do that, and we'll do const type parts at yes. So we'll do that, something like that. Then we'll just say if type equals path and name D, and then here we'll have just all our special cases, right? And otherwise we'll just do this, and then we'll do build log name val, right? And then here we'll do the same thing, but with that, right? And then we should be able to convert this using this. And I really don't like this representation in this console, so I might have to switch over to this quote-unquote full-time, the actual proper browser console, right? So here we basically want to do this instead. We want to run this through this conversion, so we don't have to figure out this string encoding for paths. But we also want to have the scale. So probably what we'll do is we'll have like an object with kind of a scaling factor built into it, something like that. I don't know. Because the other thing is I also want to be able to render partial items. So I don't want to generate a full SVG from scratch. I want to be able to do partial SVGs, right? But we'll probably have a scale here. We'll do something like this, scale. And it'll be just 1 for now, right? And then these will be perfect. Right. So the scale will be here. This will be times scale, right? And then RCP to path, we'll just do 100. For now, we'll just do constant SVG scale, something like that. Like that. Oh. Or sure. C and R. C and R should be. That should come out. L N A N A N. Scale. Oh? RC2 path data. L. Scale. And scale. Why is multiplying C and R by scale not a thing? These should be numbers. We're multiplying them by another number. Oh, is that because of the new line over here that I ended up with somehow? Yeah, somehow it was because of the new line. Okay. Not sure why that was a problem, but here we are. Okay. We still have a bunch of NaNaNs here. Well, let's find out. How exciting. So we have R, C, and then we'll have the scale. We have R times scale. Why is this R, C times scale? Okay. So R. Wait, what? Oh, because it's an area of. All right. Because we have an array of elements of path segments, right? So we need to unravel those. We'll map them and then join them, right? We have to kind of do this. We'll have to do. So we'll have to do l.map rc2path data. This. Afterwards, they're getting joined. That's what goes in here, and that's also what goes in here. And this comma goes away, and we should have something useful. Not quite. Oh, type string error is not a function. Oh. Mapping goes. Oh, I see. And that's why I didn't have a second argument. Okay, for now, let's just do this. Get rid of the scale argument, and then we'll figure that out. This whole thing needs to be within a what's the word? Within a context, right? Okay. All right, so now this looks like something more sensible. And now if we add something like, we'll do something like stroke -0, align with, we need to quote that, 3. What do we end up with? Okay, we'll end up with a massive grid. But because the scale is 100, it actually matches with the 100 by 100 rectangle. Here we go. So that works. So now we can get rid of all of this. That. Get rid of that. I feel like I wanna make this function explicit. Do RC. I almost want to do that the inner function. What do we call them? Here. That's just this inner function. We can do this. It's gonna be that. Okay. And we can just map that. Right? And then the lines we can do we can do something like RC list path data, basically that list to map. And then all of that is abstracted away up here. We can just do that. Val. Right. And that works like that. And now we want to do something similar for the rectangle. So we now get rid of that. All right. And now we want to add another element we'll call children. Well, before we do that, well, let's make sure the SVG element is a little bit better. So we'll just say if parent is passed in. The problem is we don't have the namespace. 1 second. I'm gonna pass in SVG is a second argument now. As a sort of optional second argument. Secondly, I'll output that like that, because we can probably have that as a default sort of constant. SVG namespace URI. Let's do that for now. Do that. No, we don't need parent. We can just say if parent will do that. So now we can generate these elements in a vacuum without a parent, and then we can attach them at a later stage. Right. And can we use them to generate the SVG element as well? Yes. Here it is, right? So we can just do this. Let SVG equals just say type SVG, and then we'll get that. Here we can just say return element. And then we don't need that anymore. And now we can say something like attributes width 100%, height root 100%. Fingers are pressing keys that my brain can't cash in. Here we go. Unexpected token. Column, width, height. Where? Width, colon. Oh. Not an array. Ooh, this coffee was cold. Blech. Okay, look at that. So now, I also want to be able to just attach children. So there's, and we're kind of building a bit of a DOM here, which is maybe a little overreach. But for example, what I'd like to be able to do is, I want to be able to add children to this and then just update this. So it won't recreate the element, right? But let's try something here. Let's comment this out for a sec here. Right? And then we'll just create this again. Like this. So we can say let svg part equals. I'll do that. And then here we'll have children. And then inside the children, we'll add our little rectangle here. Something like that. Right? And let's I'm gonna single line these quickly just to make this a little bit more parsable. And then we'll do the same thing with the parts, with the part path. Right? So we'll do that, single line it, something like that. Right? And I don't understand, I'm kind of reinventing the DOM here, but there's a reason for that. There's a logic to the madness, right? Then we should be able to do something like this. Let lines equals svg part dot children 1 dot attributes dot d. And now we are missing some kind of brace somewhere. What's the error? Second race here. All right, now we can fill in the lines like we did before. And then we should be able to just do this. And it won't be part of the DOM. And we should be able to just say svg part, what comes out of this render function. So it comes out like this. Oh, because we're not taking care of the children just yet. So we're doing the attributes first. And then we'll do if children, like that, do for const child of children child part of children is not defined. Children. Oh. There we go. So that should output something for each of these. Cool. So now we're gonna render these recursively. And at this point, I'm not even sure if I want to include parent here. But, you know, I guess we can. Boom. Do that. And now we have a bunch of undefineds in here. Okay. Parent part svg render part. I'm passing the function for some reason. And here we go. So now we have the svg document with our rectangle with our path element. And now we should be able to just attach it to our actual document like this. Right? So we can say let svg equals that. Then we'll append child, and here we go. Now, what it doesn't give us the whole partial subrender and update and so on and so forth. And I'm not sure if that's something I want to look into right now. But we have a little bit of a tiny framework here. It's super basic and simple. And hopefully we can expand on this, right? So, for example, I'd like to be able to do this at the top and then just amend the children. Now, the problem with that is, kind of how do you do the diffs, right? For example, if I have a group element, I might want to modify the children of that group element. How do I know what the difference is from the existing one, right? You'd almost need the reverse conversion And, you know, that maybe I don't want to really do. Probably for our purposes right now, we can probably handle replacing the whole thing, especially since the animation layer will be kind of separate in SudokuPad. Because one of the problems with replacing the whole SVG is that any other things that reference the grid lose, their references won't be valid anymore, right? So if we just replace the board with a new one, with an updated one, anything that links to existing elements, which is how the cells update themselves, won't work, right? Now, what we could do is we could create an internal mapping, but we need to store that somewhere, right? And we don't really want to store it within here. We kind of would want to store it within there. But we'd probably need some sort of active manager thing that handles that for us, right? So we'll probably, you know, kind of like a shadow DOM. Instead of just having the SVG elements verbatim, we'd basically have a parallel tree, which each element would have both a reference to the original data, and we'd have to clone it, right? So then we can detect differences. Well, we'll see. What we could, however, do is potentially update or replace an element. So, that's an idea. So what if I don't add lines to the path element, right? So let's go here. We'll output the SVG element as a string here in the console. And the path element exists, but it's empty, right? So let's say let path element equals SVG dot children 1. Now, I don't know if that's actually how we can access these. And there might be other children. Okay, no, like 2 children. Because DOMs do all sorts of weird things in HTML, especially. You know, it might add an extra child for a blank line and things like that. So we want to be careful about that. But this implies to me that we might actually have a real reference to this path element here. Whoops. Like that. And now what we might want to do, all right, what we'll do now is we'll do this like that. So now we've created the original SVG with this, but now we want to update the SVG. So we'll just say something like const SVG update element, right? And then we'll pass in the element and the part. And this will do something fairly primitive. It'll basically just replace one subsection, right? It'll remove the element and replace it with a new one. So it won't try, for now, it won't try to update it. So we'll do something like this: SVG update element, SV path element, and SVG part. All right. We have an element, and we have part. All right. So the element will be our whole SVG thing, and our part will be the lines object, which unfortunately doesn't render very conveniently here. Down here in the browser console, we have. Wait, let me do that. I'll put other things here. Yeah, I'm putting that here. I don't want to do that. Right. So the part is the whole thing. Oh, yeah, no, we want to path element SVG part. Oh, so sorry. Path part is gonna be this, and then lines are this. So not SVG part. We want to update the path part. We don't actually, I hope I don't need a reference to the original document, right? We should be able to go in here and just remove it from its parent and replace it in the same location, right? And let me just check into that. DOM replace element Replace with. So can we replace an element in position? Replaces this element in the children list of its parent with a set of node objects or strings. Strings are inserted equivalent text mode. Set of node objects or strings to replace. So we should be able to simply do we should be able to do lm dot. Okay, wait a second. We wanna I guess we'll need a reference to the parent. And this obviously won't work for an element that's that doesn't have a parent, obviously. Undefined. Lm.parent. But parent element. Or do we need a node? No, we want an element, right? So we should be able to do this. Then we should be able to do replace with lm. And then we'll do this. SVG render part. And we don't give it a parent. And then that should update the SVG with lines, except it's not. Now, what I find interesting is the SVG has disappeared. Is it something I broke earlier? No, we have the red one here. If we do this, and then we do that. Huh. So parent element is that. And if I do it after this, it does that. So, wait, what? lm.parent. Wait. Const parent. Let's get a reference to the parent because I don't trust what's going on here. Something weird is happening. Something like that. So the path has disappeared. Okay, let's say const new lm. We'll do that. So new element should be this. So we have this path. So we're telling it to replace this path with this path, and it doesn't do that. So this doesn't work. Set of node orders, string to replace. Replaces this element. Oh, okay. So we don't even need a reference to the parent. So we should just be able to do lm replace with new element. Aha! Okay. So we don't need the parent. We don't need any of this. Boom. And it's basically just that for now. So we'll keep the function because in the future we might do other things, right? Cool. So if I do something like, let me get the sleep function over here. Sleep. Right, do that. That at the top somewhere. Helpers. Sleep, right? And then we'll do await, sleep. I think sleep we need to pass in milliseconds first. So we'll wait 2 seconds and do that. 2 and update. Perfect. So. Quick look at the gritty thing. Because this doesn't do the cages. And that's something I need to figure out now if I want to do this with styles. Probably we want to have a better styling system, like use CSS styles. So we, yeah. Let me see how we have render grid cells. So I think the cages are done separately, right? Where about that? Let's find the basic styles. And then we'll have killer. And then we have boxes. So render cage. Okay, so we have So the boxes would be a box. Scene dot boxes. Somewhere over here. Why is the music stopped again? Video paused. Yes. Why did the video pause? What the heck was that? Now it said thank you confirming. What? YouTube? You be crazy. I got signed out. Why did I get signed out of YouTube? Oh my god, did that mess with the stream? Why did I get signed out of YouTube? This is insane. Is the live stream still going? Did it just disconnect me from the live stream because it decided to sign me out? This is insane. No, it says I'm still streaming. Something went wrong. YouTube, you're crazy. Alright, it looks like the YouTube stream is still running. But I get the something is wrong monkey in YouTube Studio, which is insane. What's wrong? Come on, empty cache, hard reload, and it's still gonna get an error, isn't it? I don't know. I don't know what YouTube is doing here. But it's pretty dumb. Alright, looks like we're still live though. I don't know why I did that. Okay, thanks YouTube. It's done that before. I don't know why it would log me out. Hey Neil. Yeah, thanks for letting me know. Okay, let us make a Sudoku grid, I suppose. So, we have that path. We need to, and we'll probably want to wrap that up a little bit, into a little function, perhaps. So for the boxes, I guess we also want to look into turning a list of cells into a cage wall. So I think render cage might be the right place to look, because I think it uses cells find parse RC render cage waypoint slice center point. No, render thermal. Render cage get cell outline. I think that's the function I'm looking for. Because I've spent quite a bit of effort in this function, so I'm gonna use it. I'm not gonna reinvent the wheel there. I've already reinvented plenty of wheels. Alright, so this function is actually fairly complicated. Now the question is, can we make it independent of the current render? That's the real question. If I do this, right, the rest of this should work pretty well. It'll have a bunch of stuff that are potentially external references, and those are the ones we're gonna have to find. All right, let's make this a 500 millisecond sleep. And I don't know in here, it's a complex-ish algorithm because I wanted it to be very efficient. I can just run it as often as I need it, and I didn't have to worry about it. So it takes a list of cells, but what do these cells actually expect to look like? So a cell has rows and columns. Where does the grid come from? Grid. Okay, so let's see. If I do this and I do this up here, and I'll say each cell is expected to have a row and a column, and we might change these to RC values, but for now I just want to see if I can get it to run. So we'll have an array of cells. Let's see, does it work with an empty list? Argument after list, like that. Okay, so if I want to create a cell at row 0, call 0. And that's our sole cell in this outline. It should get us an outline around the first thing. Okay. So we're gonna put that before the weight here. So let cells equals, we're gonna do that. And then let outline equals cell outline cells. We'll do that. Cells. And now the outline is a set of lines, so we should be able to add this to the children. So we should be able to say render part, new part, type is path. Type is path. Outline. Attributes is stroke red. And we're gonna add that to the SVG element, which is this one. And we're gonna make the attributes like that, and we're gonna have an attribute called D, and that'll have this outline, right? And let box part equals. Let's have a look at box part, because this should be we haven't added. No, we've added the parent in. So if we're looking at SVG again, SVG children should now include our box part. So we have the outline here. Number 0 is not property symbol iterators. Okay, so outline. D is supposed to be an array, right? But the outline I think gets already converted. Outline is... Oh, okay. So outline is a very different beast from what we did with the paths and the lines earlier. So these get mapped like this. Render cage. So that's kind of what I'm figuring out now, right? So we want new low-level primitives. So we don't SVG paths. We want to be able to render cages, right? So we're going to do that, right? We're going to say this is a cage. And then instead of... Maybe we don't even go into attributes like on these higher level things, right? We don't need the attributes. Or we can have the attributes as well. But the attribute will just be the color for now. And later on, it'll probably be coming out of some sort of styles or whatever. And I'm going to do it like this. My own peace of mind. And what we're actually going to do here is we're going to do cells directly like that. So then we should be able to look at these. I'm going to move these down. Like that. Get cell outline becomes part of the higher level stuff. Right? And now we want to look at let's get rid of those other logs here. And we don't need outline at all. Excuse me. And now we're going to look at these guys, right? So we'll set up the attributes anyways. And maybe we'll do the same thing for here. So D is still available as a sort of raw property, but when we're doing our custom path thing here, our custom lines, we don't put that here. That just goes here, one level up, right? So we're just using these for the raw pass through. And then here, instead of doing this, this becomes lines, right? And then over here, instead of doing that, we'll just say if art.lines art.lines art.lines. Ah, my fingers are typing faster than me. Okay. And then if we have path.lines, we know this needs to replace the D attribute. So we want to do it before this. So it can be overridden. So then we'll say set attribute part.lines, and the attribute that we override is D. Right? And then we'll do the same thing for cage. The only issue with cage is we need to modify the type here. So, maybe the lines thing should be its own property as well. Because basically we want a mapping here. So const map parts to types. Map part types equals, and we'll just map everything to itself except for cage is mapped to path for now, right? So we'll do console.log part.type. It's part.type. Part.type. And finally, I want to see what our part.type that looks like. I think that'll work, right? So part.type, cage becomes path. Path becomes path, rect becomes rect. Okay, so we'll just do something like type. We'll do something like type equals this. And the default value should be, what's the default type? Group? SVG elements. Is there, because for HTML, obviously it's div. I don't know what it is for SVG. They're all kind of specific. View. Ooh, is that something I want to play with? Particular view of an SVG specific can be displayed by referencing the element's ID as a target. Does that mean I can cut out a piece of an element and put it somewhere else? Block. What the? Right, let's not worry about that for now. Probably a group might be a good default. So we'll just do that. And part types const SVG part type default. SVG default part type default. That's just B for now. And then SVG part type map. Goes here. Right. Now we can just say, what's the actual type? That should always make sense. Shouldn't give us any kind of problems. Right. And now we can do some more of these. If part.lines, part.cells, S3G, we'll probably want to call this SVG type. So we'll probably want to do type here. We want to do default type. No. Want to do this here. And then SVG type here. And this needs to be SVG type. And we'll probably move this to a let further down here. Something like that. Right? Type has already been declared. Type. SVG type. 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 We're not redeclaring anything here. As far as I can tell. Missing initial and const declaration. Next bit, end of input. Declaration, missing identifier. SVG type. This looks fine. End of input. Means it doesn't know where it's going. Which means I've messed something up here with the braces. I don't see it for right now. Open bracket, close. Oh, is it this one? Is that it? Okay, part.cells. Okay. And Neil, I promise you we'll soon get to the interesting part for you. All this programming stuff must be a little bit boring. Oh dear, oh dear. All this preparation. Yeah, so type should not be... Type should be... Not be path. Type should be... cage. At some point, there should be a type cage. Here we go. Now, the question is, does this other stuff make sense? I don't know. We'll see. But for now, we can just hide these. Part.cells, right? So if we have part.cells, we basically do something similar to the other one. With the lines. Just now, we'll do it with get outline. So we'll do that. Part.cells. And finally, if it lets me put that in a nice plot, we'll do this. Oh, didn't like it. Okay. What does it not like? So it gets us this. Oh, okay. So we can't just convert it like that. We need to convert it the proper way, right? Not here. Edge points becomes this. So it's this thing multiplied to okay, so that'll turn us into this TRC. Then the cell size is our SVG whatever. Now, can I reuse this thing up here? Sort of. In fact, we'll have to do it the other way around because this one is more generic than the other one. So we'll need to build something that can support this. So let me move these higher up here. Like there. there. Right? And go here. Go top. Like that. So we now have something that takes, and let me do that here as well. Lines. And is that 2 lines? Fortunately. Yeah, fine here. I want to look down here. So it takes these lines. It doesn't convert them. Part.lines. Array. Part.cells. Ah, here we go. Part.lines here. So it turns this into this. And the part.cells is where? Here. And what does it create? It creates this. And how does that compare to this? Okay, so these are all gonna be L's. So we want to do something that doesn't add the M and L and uses the ones that's given. So const RC path to SVG path. And these will be kind of with a type element. All right, so TRC to SVG part. TRC to SVG. Path to SVG. So we have a TRC. Right? And then we'll do something like this. Part.cells. I like that. And our TRC should now be something. Part.lines. We're gonna comment this out for a sec because it's so spammy. All right, so that gets us the, no. We want to process that. Let us move this over to the right, I think. Ooh, here we go. We might get rid of this console in the end. It's as useful as I'm hoping. So we have this. And we now need to convert that to the data in what's the word? In SVG, in an SVG path, right? The D property. So trc.map. We got that. We got that. If t is z, we'll just output the t. Well, we're always outputting the t. In the end, we're joining. We can probably do something a little here. Kind of want to do this. Then this. This. Get rid of that. And we'll have that. Right? And instead of cell size, we'll use SVG scale. Right? And now that should get us this. Okay, so that works. It goes from that to that. And we kind of just do this, really. Right? C to SVG. That's really just this inner function here. Boom. Like that. And then we can just pass that into the map here, do the join. I feel like I'm missing something here. IDX isn't used. Here C to SVG. Yeah, have the T here. Then we have that. Then we have that. And then we have that. Oh. We're outputting the function here. Just returning different. Not so much boring as a bit instructive. Not code I could write. Yeah, potentially not good code either. It's almost like I've drank in too much functional programming Kool-Aid. When I was a kid, like when I first learned programming in like the first year or two, for a while I got really into functional programming, so I kind of re-implemented functional programming in Turbo Pascal. I even implemented my own, I built my own garbage collection in Turbo Pascal, so I didn't have to do memory allocation things. So I did all sorts of weird stuff. Over the years, I've created a couple of different programming languages, all just because it was interesting and, you know. But I've always felt like it was a really good foundation to just, I don't know. Like, I always felt like if you know how your tools are made, you can use them better. I don't want to build a real programming language, but by having built my own, I think I'm less surprised by weird things that programming languages do, you know. And I find it easier to understand programming languages I've never seen before, kind of in principle, you know. All right, so let me see. We now have this. Now what I'm doing is basically I'm kind of reverse engineering my list thing because this function is sort of more fundamental. So now that this will internally actually start using this function that I've just created. And I should be able to now do something similar here for this, or taking a list of cells instead of a list of lines to generate SVG path data, kind of like this. Stroke and blue. And maybe instead of row 1, we'll say row 3, column 3. And if I say fill none, and we'll probably have to set up some defaults and all that sort of stuff. And if I do line width 3, nope, stroke width, SVG stroke width, stroke size, stroke width, I guess right, stroke width, right? And the beauty of this algorithm is that I can just add additional cells. You know, if I add the cell next to it. I sometimes forget that mathematicians aren't the same thing as computer science professors. Because the teacher who taught me at school, her husband was a computer science professor at university, and I had some classes with him. And I had a good relationship with her because I was basically in all her classes and all this stuff. And he, at the time, had created some really cool, like, I don't know what it's called, not simulation, but like the kind of algorithms like the kind of system you would use to map or to model something, like a complex system, right? And it had like a visualizer, so you could like put logic gates in it, and you could press a button, it would the lines would light up and all this sort of stuff. So it was, I guess it was like a research tool, but he was kind of old school. So it was like, I mean, this was mid-90s. So he was still stuck on Turbo Pascal, and this was all pre-internet and pre-HTML. So it was all about everything was kind of more fundamental and more like the basics and systems programming and all this sort of stuff. One other thing is this one, no, not this one. This one has an inset, right? So I should be able to do something like 4. And it should put the outline somewhere else. No. Sorry, an offset, right? So get cell outline offset 4. Doesn't seem to work. Oh, because I didn't put it in the right place. And this is what I use for, that's relative to cells, right? Yeah, so we can inset it and we can outset it. And that's kind of why the algorithm is relative complex, because it actually generates all sorts of little bits and pieces, right? For now, we don't need that. But we can now, hopefully, conflate this one to this one, right? Because it basically... let me see. So, we have this with the ML and Ls. And why? How does it know? Okay, so the first one is the move, and the other one are the Ls. All right. So we want something that takes our lines, and instead of turning it straight into that, I want to create it into an TRC. Was it TRC? Right. So RC path pair. So in theory, if I change this one, let's rename this for a sec. We're getting an RC and IDX. And what we want to do is we want to convert it to TRC. So we'll just say this, that's the first element. This is the second. We don't do the scaling here. And we basically want to do this. Right? And now, lines, RC to path data, RC list to path data, which uses this. RC path data. And that does this. And that should create this. No, it should. Does this. Oh, because we're flattening it here. RC to path data is that. So that's not actually what we want to do just yet. We want to do so part.lines is an array of these, and we'll actually want to map them to that. So we want to do this and map them to that, right? And that now should get us the 3 elements list with the M and Ls, which basically is the move command. It basically converts our RC values to move, like to commands in the SVG sort of thing. And the next step would be the scaling when we run it through this. So now we should be able to take this thing and run it through this. And that should get us the whole thing, right? That should get us the actual path with the Z at the end and all that sort of thing. And now we should be able to just use that here. And it should actually get us our grid back already. Right? No. Looks correct. RC2 path pair. And we have the 3 elements. We have the... I'm kind of sorry, this might be a bit small. I'm looking at the raw data. Oh, sorry, lines. Oh, wait, what? No. So each line is a set of things. So each line needs to actually map to this. So lines.map. Yeah, so it'll be this map to that. Right? And that is this now. Let's just stick it in to see if that if that's correct. Refresh faster. Part So this should already have done the join and everything. I'm probably confusing because, okay, so lines generate multiple things. Oh, wait, we're down here, right. So that gets us these with those. And we need to pass this into the TRC to SVG thing. Lines, RCS map, RC to path pair. That gets us the TRC list here. But does it get us one per line? Yes. So, this gets us one per line, which we then want to map to this. So this is, we want to do this, then we want to map. Now what we get here are, map. This gets us the TRC. Right? So that should get us the TRCs. One per line? No. One per... Shoot. One per RC2 data. RC to path data. RCS. No. TRC to SVG. TRC to SVG path. God damn it, my brain. So let's do these separate. Then we'll do RC to path pair. We'll put those in here. We'll just comment these out for a sec because this is a mess now. Right? So what do we get? So we have the lines, which are our RC values. So they're not cells, they're lines. Except each line is made out of multiple points, right? Then we turn these into these objects, right? And these objects should be similar to what we've done with the cells earlier, which is these things, right? Now, we have one of these with 5, and we have one of these with 1 per line. So in theory, we should be able to pass that straight into whatever we did with the cells, which is this, right? So that should be able to take a list of that and turn that into an SVG string. And if that doesn't work, and it doesn't, then I have to ask why. So it's mapping each of these elements, and each of these elements is a TRC element. And it's mapping them to this, where the R and the C are multiplied by the SVG scale. Right. RC. Yeah, we don't want to swap them here. But that still should matter. Right, so we're taking these, similar to what we've taken here. Oh, no. No, 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 no. Wait, what? Shoot. Oh yeah, okay, so I've confused that. Each of those is a line. Each of those is a line, while each of those is a mess. Okay, so the errors in this part. Okay, so part.lines needs to turn into each line. Doesn't go there, it goes to it goes to line to RC list to path data. RCS to TRCs. So we want something like RCS to TRC, right? Which takes one RCS, right? One list of RCs, which represents one line, and then maps each one to one of these guys. So we'll do rcs.map, and we'll have this. Wait, what? RC to path data. Yeah, so it's similar to this, really. So it'll just RCS's to that, but without the join at the end. So we want to do this. RCS to TRC for each line, right? And it'll be this. Okay. And now each of those should be able to pass through this. So now we should be able to map these are TRC and they get passed through this or whatever, right? Just go straight into that. Right? And it gets us an array of these, one per line. And then in the end, we just join those together. So we take these and then just join these with a space like that. And that gets us our grid lines back. Okay. All right. All right. So we want to clean that up quite a bit. So TRC, RCS to TRC. So the difference here is that the cell gets converted to the outlines, and the outlines are a set of lines, right? We just need to annotate these lines, basically. So we want to do something like with get cell outline. We're using this and that, but that takes a single set of TRC, so that takes one line. So we'll do const line to SVG path, right? And the line is an RCS set. And now with that, we can do RCS.map yada yada. So then we should be able to do this with that. And then we don't need that, right? RCS to TRC. RCS to TRC. Expected token. App join extra brace here. Let's see. Okay, so we're back in business. Now, which of these is redundant? We don't need that anymore. RCS to path pair is here. RCS to path data. I don't think RCS to path pair. I don't think this is used now. I don't think this is being used. Right. And then we want TRC to SVG, so that's kind of the, whoops, the sort of low level one. That's the one that converts it to a string at the end. That goes to the top. And then TRC path, SVG path. CS to TRC. This is a list of RCs. So, lines. Just to make it explicit, right? A line is a set of RCs, and that's why we call them RCSs. This turns a set of RCSs to these. And then this converts these. This is TRC to SVG, right? And for the other one, oh, these are much shorter now. These all work like that, right? Here we just do the cell outline first. Line to SVG parse, TSC path to SVG path. Line to SVG path, TRC to SVG path. Line, SVG path, TRC to SVG path. So that we're executing here. So this is because it's operating on multiple lines, right? That's the kind of the crux of my confusion here. Right, for now that works. We can improve it later, right? So that now means also we should be able to look at whatever we are using over here to that we're using here to generate the cages. Up, I think. Got the renderer here. Grid. So I think we're going all the way to puzzle, where we're looking at the function that basically adds our cell cages, or our region cages. Puzzle. Parcels, create puzzle. State, where is it? I think it's, no, convert is in the application. Press clear, get rules, create puzzle. Set restart, here, load puzzle. All right, so region cages. Center marks, cages, yada, yada, yada. Cage targets, render cage. Where are the region cages? Are they getting added earlier? I don't recall. We're doing row call cages somewhere along here. Row cages, column cages, sure. And they're using RC notation here. Cells to RC range. Arch parcels. Row cages, call cages. I am wondering if region cages are added earlier. Regions, handle region feature. Style box. Region, here we go. Load compact classics, okay. Where else are we adding region cages? Region feature. Type region. Where else is type region getting used? It's region row call include. Region feature. Let handle region feature. If there's no region, does it add default regions here? That's the question, right? Region feature. Okay. Load compact class. So here definitely adds the regions directly. I'm gonna look this up. I'm gonna go localhost. I'm gonna open an SCF puzzle with nothing in it. And somehow my thing isn't running anymore. How did it crash? And if you guys, okay, I don't know. Now this one has region cages, right? So let's see. When we're adding regions or when we're creating the puzzle, it's not happening in checker. This is happening here. Let's see where the puzzle data gets loaded in, or if By the time we get to here, do we have regions already? We have row 1, 1, 2. Okay. We have these. We have region cages here. Whoops. Where did it come from? Take either a bathroom break or finish the stream. What time is it? 8. It's 8 o'clock. Probably can't stream too much longer. Alright, where are we coming from? We're coming from... God damn it. We're coming from... Load puzzle, load puzzle, load. Alright, so in this case, we know we have a region cage added. So, if we go from one of these, I guess the region cage... And it crashed again? What? Sorry, I'm gonna have to look that up. Why is my server crashing suddenly? Is SudokuPad up? Is SudokuPad up? Okay, it's up. Why is my local server suddenly crashing? It really shouldn't do that. Have a quick look. In the puzzle database, we're loading... We're reloading the file backup. File info cache. Dot length. What is it at this point? Like, I don't know why it works at first and then crashes shortly after. Two 25762. So there's something here. Dot slice 0 100. And if I do this, no, sorry, this is an array, right? This is JSON data. But if I convert it to this, why would the stringification of a JSON not have a length property? That doesn't make any bloody sense. Refresh. Okay. And it crashed again. What the hell is going on here? Okay, so this is part of our cache. Invalid string length. This is the cache. This is the stringification. Invalid string length. What? What? Oh, don't tell me it's too big. Oh no, it's too big. Ah. Uh-oh. Uh-oh. We have 257,626 elements in this cache. So if we do let sum equals, or size equals 0, and if I do for let I equals 0, I smaller than the length of this cache object. Oh no. And then we'll do size plus equals JSON dot stringify one of these length, and then we'll output the size. And what does that look like? Am I hitting the maximum size of strings in JavaScript? Is that really the problem I'm encountering here? Wait, what? It's only 400, it's 546 megabytes. JavaScript maximum string length. 256 megabytes. Are you kidding me? I'm more than double that. Am I out of memory? It could use up my memory. God damn it. Node.js. I could probably change that in Node.js. Increase the maximum strength to 1 gigabyte. I've regressed back to 2 to the power of 28. The point of compression recently bumped back to 2 to... Oh, it's... JavaScript on Node.js can only handle 512 megabytes as a single string. And I'm exceeding that. Is this hardcoded in the source code? A lot of code implicitly relies on it. So while allowing larger strings is known to be in people's wish lists, it's going to be a lot of work and won't happen in the future. Damn it! God damn it. Okay, well, I'm just looking at the size here, so I hopefully don't actually have to do this. So if I do this, does that work? Okay, I definitely have to... Is that why my server crashed a couple of weeks ago? No, but my server didn't crash. It was the database server that crashed. And this has nothing to do with the database server. All right. Can we... Something happening here? Okay, now it works. That's something I really need to look into because... Oh, wait a second. Is that... This is on startup. Why would this be bigger locally than on the server? Or am I having big problems on the server that I'm just not realizing? Sorry about the derailing of the stream, but if the server's in trouble, I should check that out. This would be happening in... Production server, right? I don't see anything here. But it's definitely something I should take a look at. After the stream, for sure. Oh dear. Yeah. On the one hand, I'm happy I have that file-based backup. On the other hand, there's definitely flaws with that system. There's a reason I wanted to move to the database. Anywho, so here we have cages, and the cages come probably from the convert function, right? So if I go to convert puzzle here, so I won't have the cages here yet, right? Convert puzzle. But we have the regions here. So it's the regions that come in from, and I'm guessing this is the fpuzzles importer. All right, short break. I'll be right back. I just gotta go to the bathroom. Let me see if I can do this. 1 second. I'll be right back. Alright, I'm back. I think I forgot to mute. Make sure everything is still going. Hey. Ah, excuse me. Alright. So, where were we? Oh yes, we were trying to figure out where the cages come from. The region cages. And they come from the importer, probably. So they're in here. So let us, I guess we'll just add them ourselves. There is a parse something something function. Dot parse, not JSON dot parse, parse cell, parcels. Can I import that easily? Resolve RC. Resolve RC. Yeah, no, I'm not gonna worry about that. All right. So what we're gonna do, we're gonna go in here, and we're just gonna manually create them, right? So, actually, you know what? I don't want to do this from scratch. So we're gonna pull the little utilities function for converting RC values and all that stuff from one of the functions here. Is, I believe, givens? No. Maybe it is. Oh, I thought I had manually imported it. One of these. Permutate Sudokus. Yes. So that should get us something. We'll grab these, put them up here with the helpers. Boom, cell iteration. So we should be able to say index to region, I believe. Region to index, region to scene, region to index, get classic scene cells, box, index to scene. Index to scene box 1. So for example, if I do this and then output index to scene dot box 0 or 0 maybe, I don't know if these are pre-calculated, I forgot. So that should get us the indexes indici. But now we need to convert the indici to RC values. Index to RC, index to RC, index, region to index, region to scene, index aligned, index to RC, 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 nope. Don't have anything here, converting index values to RCs. Okay, I can do this myself. I remember how to do this. Sure. So that gets us all the indices of all the cells in box 0. And we can convert this to I modulus 9. Right? So that should get us 0, 1, 2, 0, 1, 2, 0, 1, 2, right? And then we should be able to say I divided by 3 or 0, something like that. And that should get us 0, 0, 0, 3, 3, 3, 6, 6, 6. 0, 0, 0, 0. No. Wait, something's wrong here. 0, 1, 2, 0, 1, 2, 9, 10, 11, 18, 19, 20. So the first two is our column, RC, so that's our column. And then our C, not divided by 3, divided by 9, right? So that'll be 0, 0, 0, 1, 1, 1, 2, 2, 2. So if I do this, divided by 9, modulo, or 0. Yeah, okay. So we should just say IDX to RC. So const IDX to RC is just that. Right? Classic scene cells, I guess, does all of these, right? Yeah. We don't want to care about those. So we should be able to map this, boom. Right? And now, if I put this into cells here, what does that look like? We actually want to do this not by row call, but we want to do this by RC arrays, right? So, yeah, that's the other thing we wanted to do. We wanted to change get cell outline not to work on row call, but on RC arrays. So, cells for each cell. So we don't cell here. I want to do our row call, basically. Do the same thing here. Right? We don't need cell here. That. That. Right? And still have an issue somewhere. Cell is not defined. Oh. Here. Darn. Okay. Well, I tried. I tried. Right? Cell's not defined at. Cell is not defined at. Cells dot for each cell pet. Cells dot for each. Same issue. Okay. Cell. Turn. This boom. And const boom to cell. Right. I'll probably did this back when I built this code and realized why I couldn't do that. So. Okay. It's not right, but okay. So if we look at box part, let's look at this first. Here's 0, 1, 1, 0. Wait, IDX to RC. Did I make a mistake here? Very possible. Let's confirm that before we do too much elsewhere. 0, 1, 2. 0, 1, 2. Not 0, 1, 2, 3, 8. 10, 11, 18, 19, 20. So that's correct. These are not. Because we have 3 elements. Oh, because hey guys! Because I'm outputting the index still on the first element. Here we go. So 0, 1, 2, 0, 1, 2, 0, 1, 2, 1, 1, 1, 2, 2, 2. Here we go. All right, it's getting exciting. So this is our black outline. We'll make it a little bit wider, right? And we should be able to do. We don't need box parts here. And then we'll just say for const region equals for let r equals 0, r smaller than 9, r plus plus. And then we'll just say this, boom, boom. And this is just r. We don't need any of that. That should get us 9 regions. Not quite. Sorry? Oh, did you just... Weren't you just out with Toby? Ah, okay. Alright, ciao, ciao. So, guys, we have a little bit more time for the stream. We have boxes 0 through 8. 1, 2, 3. And one of these, 3, 4, 5, 3, 4, 5, 0, 0, 1, 1, 2, 2, 0, 0, 1, 2, 2, 0, 2, 2. The second part is wrong. 0, 1, 2. Okay. So if we're looking at box 3, right? Or let's look at box 4, the central box, right? You want to output both of these. So 3, 4, 5. Hey, that's not right. That's not right. Not right at all. 0, 1, 2. Is IDX to scene? IDX to scene. Oh, I'm an idiot. IDX means I give it an index of a cell, not the actual thing. Okay. So we want region to scene, region to IDX, region to scene, not scene to IDX. Jeez. Okay, sorry. My own confusion. But it basically gave me the region that contains a cell with that index. Yeah, and now that's working. Cool. That's the regions. We don't need that at all anymore. Right, that's our grid. Those are regions. Cool. Let's do a little bit something. If I we'll worry about margins and stuff later. Okay, we can get rid of the red box as well at this point. That was just sort of for these kind of purposes. We can say type D. We'll do children, right? And we'll do A9. Children. I'll do this, right? Do console.log. This is just going to be an array of 9 elements, right? From 0 through 9. Okay, 0 through 8. We should be able to do 0 through 8.map R. And we should be able to do this without the parent. Don't know why you're putting it over there, buddy. Back there. R region. And we need to close that up here. Probably want to. Is that right? I do this. Look at children. Look at this. Each of these is a path element. Oh, because we don't actually want to render them yet. Yeah. What am I doing? You don't need to render them just yet. That's the whole freaking point. They get rendered all together. Right? There we go. Page attribute. But where is it struggling with the push? Is it because... Okay, wait, we don't want to do this anymore. Is it because of the path part? Because it's no longer element 0 or element 1 or whatever? Yeah. Okay. We'll do the same thing with the grid. So we should be able to do A9 here. Then we'll do A9 dot map I. That should get us something like this with an I, right? But it should also get us something like this as a separate element. Probably want to do flat map here. Flat map. Then we'll actually return 2 elements. This one and this one. One for the rows and one for the columns. Right? And it should get flattened out into a set of lines. And we'll probably just have to enclose this into round braces and add another one here. And yeah, almost Lisp. Right. So we should be able to just put that in here for the lines. Like that. We'll probably figure that out later. Lines. This should be fine. Greater. I do this. Mosquito. Where do you come from? Not the season for mosquitoes. Let's get rid of all of this other stuff here. Obviously, I prefer it all to be working, but we don't really need that. Now, I probably broke it by doing shenanigans up there. Or not. Okay, it doesn't like that. So, let's take a look at this. So, got the children here. First child is our path, which has these lines now. Oh, okay. We're missing one set of square brackets. Braces, brackets, I never know. Here we go. All right. So now we don't need any of this stuff. We have our Sudoku grid. Again, you know, probably could have gotten there faster. I didn't care, but we have certain sets of tools available to us now that we can hopefully use for a bunch of other things, right? Okay, so now we want to be able to set values and all this sort of thing. I think I can already do that to some extent. So if I say something like type text, and then we'll say attributes content. Oh, here. Here. Oh, here. We're doing render part. Line. Everything ends up in render part, I believe. Here. If we have a content element here, if content. Okay, so this is a bunch of clever stuff. All right. I sometimes think, oh, it's so simple, and then I realize, oh my god, you did a lot of work to make this work like that. All right. So if I do this, what does that look like? I don't know. Oh no. X. Not an attribute. Is it a property? Doesn't like that. Why doesn't it like that? Attribute prop closed. Okay, so we need to handle properties now. And again, probably we'll do something more clever. We probably can do something like this. And, right, instead of doing prop, just say, hey, if it's of type blah, da, 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 you know. So if right, text and artists.com. And in this case, I'll actually want to look at this because I could imagine in the future we'll have different kinds of text, like a cell label, right? Which adds additional styling, and that's kind of what this system is supposed to represent. And then elem dot, so we'll have, let's see, mdn element that property, that attribute. But I think for properties, we just have to assign them directly. So we're just gonna go here, and then we'll say if and part of that dot text content equals part dot content. Right? If I do that, where does this text value end up? Oh, okay. Text. Now, in the actual engine, how's that different? Let's find out. So givens have text. Basically the same thing, just we have this stuff from the styling, and then a bunch of stuff here. So is the X and Y the only reason why? So if I say X 10, Y 10. Okay. All right. Okay, all right. So it has to do with a lot of all this other stuff. Text anchor middle, dominant baseline middle, yada, yada, yada. All right. For now, we're gonna have to put these in manually. But later on, hopefully, a lot of this stuff will be automated. I think we had dominant baseline. Text transfer uppercase, we don't worry about it for now. Where was dominant baseline? Dominant baseline, width line. So, yeah, I think that's to make outlines, like stroke outlines, work correctly. So then, if this is an RX position, so for example, if we want to put it at, so if we want to say, why am I weird? All right, we want to do it as RC23, right? The problem is the X and Y positioning. I don't know if that's universal, but for now, let's just go with it. So if parts dot RC, right? Part dot RC, and then we should be able to do X and Y and yada yada yada. So then X becomes our column, which is RC, is the first one in RC. So part.rc0, y, rc1, and we multiply that by SVG scale. And I'm guessing this should be 0 based then. Yeah, not exactly. So it'll be this, 0.5, 0.5. So we want it in the center of the second, so 0, 1, 2, 0, 1, 2, 3. It's quite central there, right? And then we'll have to adjust the sizing. Font size 3 RAM. I don't know if that makes sense. I'm gonna have to deal with that probably via style sheets. Because I don't know, like, how these translate to SVG units, basically. Yeah, and even to get it properly centered on the cell, I remember working very hard to make that happen. Like, X anchor middle width. Font size. Don't even know what's responsible here for actually centering it. Text stroke width. No, I don't see a transform or anything. Like, we have this. Type block, white space, text transform. Like, if I get rid of any of this stuff, like, that'll definitely dominant baseline middle. Maybe I misspelled that. Dominant baseline middle. Maybe that's not a property. We'll probably have to deal with style here. So these would all be under style. So just like we'll do, you know, kind of these things, we'll probably do attributes. So just like we have attributes, we'll probably have children, we'll have, let's, attributes, we'll do style. Where were we? We have style equals that. And then we'll do kind of something like that. Oh. This editor doesn't always do what I want. Style. One sec. My brain is not keeping up. Name value. Element.style. Is it style or is it CSS style or something? Forget. Is it style? Object entry style. Why do I have missing braces here? Did I hate something? Yeah, sometimes when it's collapsed, it kind of clones an element or something without showing me. There we go. All right, so we have style, MDN style. So style element, style dot oh no, that's not what we want. We want HTML element. We want properties, style. So this is of CSS style declaration. Then here we should be able to do things like set property. So we should be able to do things like element.style dot set property name val. Now this is something I find annoying, right? So here's set property, but on the element itself there's no set property. So it's like it's a little bit wishy-washy. I feel like it's not consistent which things happen where and all that. All right, we still don't have the digit actually properly centered. And I'm curious if that's some sort of kerning issue. or if I've compensated for this elsewhere. I know there's also the weird things that I'm doing to make things work properly. And I sometimes forget about all those things. But here I'm seeing transform origin 0, 0. I don't see a transform on this thing. But maybe the transform is somewhere else. Definitely 0, 0 here. But maybe I fixed it in some other way. Maybe no scaling grid. Maybe effective transform. Maybe on this group. Maybe I've no transform here either. Like if I take this and I move it here, it's still centered. If I move it here, it's still centered. And if I take this and I change this class, and the text is still working. I get rid of these. Text is still correct. Get rid of that. Smaller, but it's still centered. While here, not centered. Oh, wait, but the position here. Oh, yeah. Okay, now I'm an idiot. All right, so render text. Here, the X and Y is affected by 0.06 on the Y offset, and I don't know why. Is there a better way? SVG text vertical alignment. It's just wrong. I shouldn't have to add some arbitrary factor to fudge it into place. Baseline attribute specified. How the object is aligned with respect to its parent. This property specified. Vertical center. It's 2025, and I'm still looking up how to vertically align things. Now use dominant central. Central instead of middle. What's wrong? All right. Does that fix it? I think it does. How well supported is that? Find central. Central. The writing mode is horizontal, and the value of the central. Central. The base and offensive. Central. Right. Dominant baseline central browser support. Is that something super recent, or has that been around for 10 years? Oh, Firefox, please. Central. Alright, Internet Explorer, I don't care about that. Right, it looks like it should work. Right, I'm happy with that. Better than the fudge factor. Okay, so this means we can start putting things into cells, right? Yeah. Let's do something with that. So I'd like to, class names. If we say class name here, class name. Or better even, if I just say here, SVG text. For now, just put that in here. And we don't have to do that. Don't even need that. We can do that, and we can do that. Right? That should still work. Oh. Yeah. Djava is scriptify this. Right? And now we can actually add a little bit of code, and we can just generate a bunch of text bits. And now we can actually do the distance stuff. We can illustrate our 5x5 and stuff like that. Let's also look at, we'll do add ID. ID, grid. And then we'll do ID digits. right? We'll say if blah, 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 ID, blah, 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 right? We'll just make it part of the properties or whatever. If part.id lm.id equals part.id, right? So if I now do get rid of this, and then I can say svg.get and by ID digits, right? That should now enable me to, by the way, I've just moved that and I didn't realize. Nobody's been telling me anything. All right, so that gets us the digits group, and we should be able to now just add something to that. So we should be able to just say svg render part. So let's say, oops, that lm digits equals that. And then we can do something like this. lm digits as the parent. Boom. Right? And ta-da. Okay. Alrighty. Okay. Now, if I want to do... So this is our... Let's put that in a function quickly. Const test as Sudoku grid. We'll just do that, and we'll just copy that code in there quickly like this, right? And then we'll do something similar for test or draw 5x5 dist grid, right? And then we'll just say await this like that. Now, what I'm gonna do is I'm gonna create a I'm gonna create a 5x5, so that's 0 to 5, I believe. Something like this. Nope. We're gonna leave that the same. We're gonna still do the 9x9 grid here, but we don't do the cages. We don't do the cages. Right? We're missing the outermost lines. I'm seeing 1, 2, 3, 1, 2, 3, 1, 2, 3. We're missing the outermost lines. Oh. 10. Boom. So we're actually gonna do this. We're gonna do grid. We go children. And this is gonna be one of those children. Like that. Right? Right. And here we do an lm grid. And now we're gonna put a box into here. And the box we're gonna render using one of these guys, right? So I'll just make a cage. Like that. Like that. Like that. Like that. And the cells we want to put in here are going to be 0, 1, 2, 2, 2 to start with. And we'll do 2, 3, 2, 4, 2, 5, 2, 6, 2, 7. 1, 2, 3. No, that's one too many. Right? And then we'll do 3, 4, 5, 6. 3, 4, 5, 6. We'll just make a 5 by 5. 3, 4, 5, 6. 3, 4, 5, 6. 3, 4, 5, 6. I'm realizing, just drawing the lines would have been a lot easier than actually filling in all the cells. But maybe, this is a good exercise. We're just testing things out, right? So this would be our 5 by 5. And now we're going to fill that in. So we're going to do for let row equals 0. Row is smaller than 5. Row plus plus. And then we'll do the same thing for column. And I need to do this and this and this. Right? Console log RC. Right? So that gets us our 25 row column values. But now we actually want to make them relative to the central value here. So we're kind of going from negative to whatever. So we're going to subtract -2, right? -2. Right? And then we kind of want to calculate the distance, which is just that value, right? It's just that. So it's math square root of this squared plus the same thing for the column value, right? That should be row column, not X. What am I doing? And those are the distances. Now, we don't want to put them in with all the decimal places, so we're going to have to round things a little bit. But we'll do LM digits. We're going to get our little digits group out of here. And now we should be able to put something in here. Yeah. Except instead of a 9, we want to make it relative to these. So it's going to be row plus 2.5 because yeah, and we're doing column plus 2.5 because we're kind of centering around this cell. Sweet. And now content is going to be this. Let this equals down. We'll do this.to fixed 2. So unlike SudokuPad, I'm going to squeeze decimals in here. Yeah, maybe not that many. Is it going to still be centered? I think so. Yeah, look at that. Look at that. Needs to be smaller. I guess we should be able to override the styling. So we should be able to say something like style, font size, 1 rem. Like that. Right? And the music stopped. Somehow, despite me having clicked on loop 3 times, it still somehow lost that information. Maybe the browser crashed because of the memory thing before. I don't know. All right. It doesn't like something. Style. Doesn't like that. Hey, look at that. All right. So, for example, this would now represent the grid. Now, obviously, this is a relatively large amount of code. So, hopefully, that's something I can reduce. So, for example, I might have, shortcut functions like create text and So like I could have a function. So let's say, I don't know, let's prefix it with mk for make, or I don't know, or like let's say something like part text, and it'll just take the text and the RC. So it'll take RC text, right? And it'll return something kind of like that, right? So it'll make the type text, it'll make the RC values here. Maybe it'll even add the 0.5, right? So it'll be cell center relative. And then it'll be this, right? And that'll be one of these helper functions, basically. So we can say part text, and then instead of this, we can say R plus 2, C plus 2, this, boom, and then we can do extra bits in the back, like that. That, right? And then here we can do blah, 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 extra. And we can just say object.assign, yada, yada, extra. So that should take font size into consideration. It's smallish, I guess, right? But it's, you know, it's something. Probably go up to 2 here. And we can do similar things for, like, this stuff, for example. So, like, we can say create region, right? So it's like const part region, and the region should take cells, pretty much just cells. And it'll then return something like this, where the cells go in here, cells like that, type, age, get some attributes, get some cells. And then here we can now replace, let's do the test Sudoku grid as well, like that. We're actually doing 2 on top of each other, I think, here. Maybe, I don't know. But should be able to say something like part region here. So children become this, part region, without any of that stuff. Like that. Like that. And then we can probably do something with a grid as well. We can probably do something like this. Put the grid in here. Put these in there. Something like that, right? We have our Sudoku board here. And then here we can do part text. Part text. 2, 3. Content. Like that. Oh, there we go. Where's that being output? No, not it. Where am I outputting that? Oh. Here somewhere. Here. console was cleared. Yeah, fine. Wrong thing there. Why does this not work? And body append child. SVG part. SVG. Grid. Where's the second grid? There should be 2 grids, right? I'm not imagining that. Oh, because they're both aligned on the top. If I say something like SVG, yeah, so we don't really want them to be 100%. Excuse me. We want them to be, currently we want them to be 9 times SVG size. 9 times SVG something. What's these? SVG scale. If I do that, and scroll down, we can probably reuse that here. Ah, here we go. Look at that. Technically, yeah, they'll even go next to each other. Sweet. All right, if we reduce the scale to 64, oh, it is already 64, 32, it'll be half the size, right? But it won't scale accordingly with text and stuff. Okay, so we'll probably need to figure that out. We don't want to make that all, we don't want everything to be relative to everything else. All right. But what I can do here now is, if I do this, I can add style here. Then I can say position absolute top 0. And that should technically overlay it onto the other grid, right? Top 0, left 0. That should technically overlay it onto the other grid. Ta-da! Look at that. Not actually as useful as I hoped. The region borders are kind of in the way. But in theory, we can also now make this just 5 by 5, right? We can do something like let W equals 9, height equals 9. So width, height, and then array, or just say size equals 9, right? We'll do size. Then we'll do size plus 1. And these are all size. And we'll skip this one quickly. Right? Now, we can change the grid via doing this. Hey, look at that. Look at that. Okay. Lines. That's our grid. And now we can reposition these. Just adding a different thing here. Oh. So we'll probably want to do like a path instead of cells. We probably want to do lines, right? And then each line is gonna go from 1, 2 to 2, 3, whatever that means, right? Let's see. Is that gonna render line? Or am I misunderstanding how this works? Lines underscore cells. Okay, we need a comma here. So that does indeed draw a line. So we should be able to do from 0, 0 to 0 size. Like that, from 0 to 5. And then we can go from 0 size to size. Right? And then we can go from size to size 0. But we can also do this as a single line like that, I believe. If I make it a bit thicker, this is gonna tell us if the line is closed. 1, 2, 3 lines. So we want to go back around to 0, 0. I mean, in theory, we could just tell it to close it, but, you know, this will do the trick. All right. So then we don't need all this shenanigans. All right, can we clean this up a little bit as well? Sorry, not this. This. So these are the lines, the grid lines. I mean, yeah, we'll probably want to have a grid lines function here. Something like part region. We want to say part grid. Right? And we'll probably want to give it a start and end, right? So it'll be R1, C1, R2, C2, like that. And you need to know how many as well. Or we'll have an RC, and then we'll have a width and a height. RC width height. What am I missing here? Grid RC width height. This one is wrong. Right. Let's make this function work. All right. We want at 0, 0 a grid of size 5. Okay. So we should be able to take this whole thing and now this is size plus 1. We'll probably do width and height separately here. So we'll have something. And then we'll do array width dot keys. So array width dot keys dot map width height. We'll do a horizontal first. Map I. What does that look like? Doesn't like that. Invalid array length. We need to do this and this. Invalid array length. Array H Size. Width and height. I want to be able to do rectangular rigs. I'll definitely need that sooner or later. Okay. And then for each of those, we'll actually do one of these. So that's gonna be, it's gonna be a line from, for each element in height. So we're starting from the top. So column 0, so it's from I. And then since we're going along height, this is the row value, right? So it's row 0. Row 0, comma, row width. Oh, yeah. I believe we need a bunch more brackets, braces. One of those. All right. And then what do we get? We get an array of these line elements, right? So each of these represents a line. So from 0, 0 to 0, 5, from 1, 0 to 1, 5, from 2, 0 to 2, 5, 3, 0. So the first number is the row. So we're going down the rows. And the column is from 0 to 5. Okay. And then we'll do the same thing for the columns. So that's along the width. That's the column. It's 0C. And height C. And that's for the columns. And now that's an array with 2 sets of 6s here. So we gotta do that. Right. And now we have a single array of lines, including 5, 5, and 0, 0. And now if we return that like this, we'll probably have to put the extra in there, just like we did for the text eventually. Right? We can now add this as children. So if I get rid of this, this part grid should now return a singular path. So if we do this here, does that take care of the children? Yes. If we avoid this, does it still work as expected? Yes. Okay, cool. We have a little helper that makes a grid for us. And then we don't have to write all this mess down here. And this is getting smaller. And that's exactly what I want to do. I want to build these little primitive tools and then compose them. And then later on, we'll probably have to make them a little bit smarter to make them work for animation, things like that. And there might be some metadata and some state and all this, but we'll see, we'll see. So this is the 9x9. So let's see if we can do the 9x9 grid. If we just do this, font size equals 9. Right? And then if I get rid of this and this, ta-da, right? Why are these lines thicker? Let's get rid of this for a sec. Are they aligned in a weird way that they like abut against each other instead of overlap? Maybe. No, they shouldn't. They should be perfectly on top of each other. But there's probably some anti-aliasing that makes it look a bit strange that I'll have to check into. We'll do size. Size. All right. This won't work for arbitrary sizes. We'll have to think about that. But hey, that's not too bad for a full Sudoku grid, right? And then this is our little circumference thing. Sure. Let's see. So we have our little grid here. If we do this, we're now aligning it like that. And now we can do something, right? So, try to get rid of that. Standing at console, right? Return SVG. So let x5 grid equals this grid, right? So now we can say something like await sleep 500 like that. And we can say this grid dot style dot set property left SVG scale. We kind of just do this. PX, I guess. One time. Okay. And top would be 3 times. No. We want to move it down by 1 and left it by 0. Boom. That gets us the 0, 0 on the 9. And then we'll do something like after 1 second, we'll whatever, right? So the idea is then we can say, oh, you know, let's look at 6, 6 or whatever. So we'll be at 3, 3, something like that. So, and then, you know, we can slide it, we can animate it, you know. We're jumping it right now, but obviously we can, you know, I know how to animate stuff. Maybe even pull in GSEP or an animation library or something, so I don't build everything from scratch, right? But the idea is now, we can, let's say, if I go into my test digits here, not these, some of these, right? If I take something like this, now I'll go, instead of the 9, I'll do this. Sudoku grid. I'm going to return the Sudoku grid. Return SVG. Right? We don't do this. But we do let Sudoku grid equals boom. Then we'll do Sudoku grid blah, blah, blah. We'll do that. Right? Okay. And then we can go do something like dot split dot for each. We'll have a digit and an index. Digit, index, IDX to RC. That should get us an RC value, right? Yada, yada, yada. And now we can just do one of these for each of those. We'll put the D in here. We'll do const RC equals this RC. And Nipperuni, we'll have that. Let's stop this here for a sec. It obscures our beautiful grid. And here we are. Look at that. And just to double check it, if I do, let's see, SCF. Boom. Right. 698, 698. Different font, that's fine. There we go. So that loads in an SCV grid, and that's really not complicated. Like at this level, right? Yeah, and we can definitely abstract a lot more things away, you know, like we can have a function for a whole Sudoku grid, right? So it's like, you know, const part Sudoku grid. And then we'll say width or size. And then we can, here we could abstract away region encoding, right? How to calculate the region sizes, automatic 6x6, 4x4, yada, 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 right? Size equals 9. And we kind of just do this. And probably here, we wouldn't do this. We would put it inside a G, for example. We'll put it like a G. And then the G will have the children. And we'll have a digit group and a grid. And then this is not really an SVG part, right? So we're just gonna return that at this stage, basically. Don't do any of that stuff, right? And now, instead of doing this, we'll do part Sudoku grid, make it a 9x9, and then we'll do the SVG here. Boom. Type SVG. Right? Let size equals 9. And then here under children, this will go like that. And now we want to do all this stuff. Under part. Okay. Everybody understand what's happening here? So that will get us an SVG part, which is our Sudoku grid. Boom. And all we need to do now is attach it to our HTML document for it to show up. Boom. Right? In theory. Nope. Did I bracket in the wrong places? Part Sudoku grid. Return an object. Because children needs an array. Okay. That's something I can make it even tolerant to. Doesn't matter. Doesn't like it still. Attributes. Missing this one. And Sudoku grid. Oh. Oh, wait. That should work. Let's see. That should get us an SVG here. With a width and a height. It's got nothing in it. Does that not get us a part of Sudoku grid here? Oh. Did I make it async? Alright. That shouldn't be async. There we go. So this whole thing just becomes that. Right? Because we don't need any of that. We can just make a Sudoku grid like that. And we can probably do some things down here. This loads in the digits. Boom. And then this creates our measure overlay and animates it in 2 steps. Hey, you know. Now, we probably want to do something like, if I do fill RGBA 000 0.3. What does that look like? 0.1. Or if I make it bright, and then make that 0.8. How's that work? Boom. Boom. Yeah. And it might even make sense to say, hey, now we have the different layers, and this goes under the grid, but above the digits, you know, that kind of thing. Yeah, because now I can imagine saying, okay, we have two grids next to each other, and in fact, why don't we do that, right? Is there anything? Can I make this even easier? I can probably map this to if I map this to this RCD like that, and then this is just RC. The index we don't need anymore. D. Pull that out of an array. Right? And then that goes here. Can we even just do this? Boom. And then just have the element come in here. Does that work? Is it because of the extra argument? It'll attach the index. What if I just output this for a sec? I feel like I've made really good progress today, especially since this is literally the first session I've looked at it. Let's see, SudokuPad animation system 0.0.1. All right, so if I look at this, I get a bunch of text elements, but the RC isn't done properly. Next to RC, if I do this, it should get me a triple array, right? Yeah, the value, and then part text, RC text. Why does that not work? Oh, because it's an array. RCD, boom, 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 RCD. Now we can do that. Right. Then, and now that should get us proper of these guys, right? And then we can do it with these. Right? Yeah. But we might as well just do that right here. All right. So now we could have another helper, const make Sudoku board digits, boom, right? We'll just assume 9 by 9 for now, but it should be able to figure out the size from the digits in the end. Boom. Then we can do that. We don't need to do that. I got that. Hey guys, almost done. And we can now say let board equal boom. We can pass the digits in like that. Again, we can you know, change it from string to yada yada yada. Board. So that should be a full-blown SVG element that we can put here. Board. Get rid of that. Get rid of all of this. And Sudoku is not defined. We're not using it. All right. And board is being output somewhere. Something's being output somewhere. Some SVG is being console logged. Here we go. And now, let me const test 5x5 grid and sync. Let me just pull that over here and move all of that into there. So it doesn't just happen all the time. It's just a little annoying. So then we can do this, right? But now we can also do another one. We can say board 1 and then board 2. Like that. Now we can have two boards side by side. Wait. The second board. God damn it. I don't mind the flight. It's so tiny. Just don't be in front of my nose so I can't see the screen. I mean, it's very tiny, but it's just moving. Okay, so board 2 should have different digits, but it doesn't because I've hard-coded the digits over here. Why would I do that? Doesn't make sense. All right. And that's it. So we have two different boards. We can do things like .style .margin equals 0.5 rem. And we can do the same thing with board 2. Something like that. Boom. And now, you know, next step would be things like, oh, look, if we look at the 6 and we overlay our 5x5. So let's overlay it on the 6 and let's not move it around. Just to avoid confusion, right? In fact, we need to move it in the negative direction. If I do -2 and -2, how's that look? Sorta. God damn freaking thing. Do we wanna add set property margin 0.5 rem? If I do that, does that affect? Yeah, now it matches up, right? So now we say, okay, we have a 0, 0 on the 6. Now, which is the closest 6? This one. So that's the 2, 2, right? So technically we want that on the other side. But that's kind of the idea. So the closest 6 is a 2, 2. Well, in this, all the closest digits to this corner digit are these. But if we now move it to this location, so I think I'm looking at this 2 now, yeah. So relative to this 2, now which is the closest 2? Well, it'll be this one, right? So it'll look at these 4 cells first, and it'll find a 2 over here. What is the closest 3? It's this one. But let's say there's no 9 here. Okay, what's the closest 9? We have 2 options, this one and this one. So we look at our grid. This one is a 2.2, and this is a 2.2. Is there any other 9s in that grid? There's this one, that's a 2.8. So it'll return 2.2, and it'll return one of these basically randomly, right? That's the only thing I haven't taken into consideration yet, is like I don't match each digit to one other digit. So this 9 might be used by more than one 9. So this 9 might be used by this 9, and maybe by this 9, right? Maybe not, but I haven't checked. For example, this 9 can look... The closest one would be this one. Yeah, so this one and this one is the same distance from this one. So it should probably choose this one. So I didn't check if it's allocating it. But I don't know. It could be that it doesn't matter, that the distance will always be the same, right? And ultimately, it only cares about the distances. So in other words, I don't think you'll ever have a case where the closer one is already used by another 9, because that other 9 would be further away from this one. That's just a feeling I have. It may or may not be true. So that's a refinement to the algorithm, but it's also one of those things that would probably affect very few puzzles and overall might not, really affect the rankings. Anyway, I feel like we've made really good progress. Quit while you're ahead, so I'm gonna end it here, but it's a good start. I wanted to do this from scratch mostly because I want to rethink about the fundamentals. I mean, the original SVG renderer I've written a long time ago, so I want to make sure I've got my head in the game. I know what's going on, and why, for example, I discovered this style central that apparently removes the need for my fudge factor. Obviously, I'd have to test it on, macOS, Safari, all the crappy browsers with their bugs and all this. Also, like, looking at some of the existing algorithms, like the fact that I had 2 different ways of expressing these, that I should merge them into one, so there's a lot of things here I can simplify, probably. So there's a lot of easy ways to already improve on the existing system. And I'd love to replace the existing renderer, not because it's bad or anything, it's just because it was always prototyped. It wasn't really built with forward concerns in mind, And the other thing is I want to really separate the rendering from the internal handling of data and all that. Right now there's, I got lazy at some points, and sometimes I'm directly doing SVG manipulations. While in reality, obviously, I want to be able to render to other things in the future, maybe to a canvas, maybe to a virtual internal representation, right? Maybe we just render straight to FFmpeg and into a video on a server, without actually drawing anything or generating XML data or anything like that, right? So having something where, obviously, this is not what we want, right? We want to get rid of this, but we want something where we have an underlying abstraction, where I can build everything without actually generating SVG and without attaching things to the DOM and all this, right? Like in this case, without these, there's nothing in the DOM. Well, there is the grid, but you know what I mean. Anyway. What shall we do to wind this up? Problems on Android to select the default font. It works when I click on it, but it doesn't remember the setting when I use SudokuPad again. With other fonts, it does remember the setting. All right, ROM planner. I'm gonna have to look into that, but probably not today. It's late. All right, that's it for today. Thanks for watching. The animation system is something I'd love to keep open source. That's another maybe good reason to kind of build it separately from SudokuPad. But at the same time, I want it to visually match SudokuPad, so I don't want to build a whole separate style set, But I want to also use it as an opportunity to simplify things and make things easier for myself. That like in SudokuPad, for example, the fact that the style sheets are handled separately makes it very hard, like, to generate the screenshots and the GIF animation, because I have to parse the page and pull in styles and all this sort of stuff. So I want to definitely do something that's a bit more self-contained. I feel like we've made a great start here today. All right, that's it. Thanks for hanging out, and thanks for watching. Take care. See you guys in the next one. Bye bye.